Hello everyone, and welcome to second day of PyData Delhi Meetup number 38. And I hope all of you had so much fun yesterday, like we all did. And today we are back with another talk by Matthew C. So let me just so we have prepared a couple of slides for the introduction, and after that we're going to jump right to the content for the meetup. So yeah, so obviously, like, what is PyData Delhi and what is NumFOCUS? So I am sure, like, all of you must have used open data source tools like NumPy, Panda, Scikit-learn, Matplotlib, Jupyter, nteract, and stuff like that. So these open source tools need donations, money, developers, and contributors to sustain themselves. And NumFOCUS is a nonprofit 501c3 in US which supports all these open data source tools and make sure that they are sustainable and they keep alive for the time running. So basically, PyData is an educational initiative by NumFOCUS, and it has, I guess, almost 160 plus chapters all over the world. And PyData Delhi started back in 2016, and since then we've been growing exponentially, and we are currently, I think, fourth largest in the world. So that's a very proud moment for us, and we've been doing meetups and conferences since past 3 years, and we have done 38. This is our 38th meetup, so we have done 37 meetups so far and 3 conferences, which had like a pretty good attendance of 400 plus people in every year. So yeah. Obviously, the meetup is live on YouTube, and you can go over to this link, and it will be redirecting to our live stream, so you can check the live stream over there. And a little bit about our speaker, Matthew Seal. So he's a senior software engineer at Netflix, which works on he works on big data platform team over at Netflix, and he's also core maintainer for Jupyter and Track projects. And more of that in a few minutes because he'll be introducing himself with a much more clearer idea. Obviously, yeah, questions. So I'm guessing like we all have good questions right now because I think due to this pandemic we are using Netflix too much. So I'm guessing you have very good questions prepared for Matthew, and I'm sure like Matthew is well prepared for the questions. So obviously you need to ask your questions, and you can go to our YouTube live chat and post a question over there. We have volunteers spread all over the YouTube live chat, and they'll be noting down your questions. And after the talk, we'll be taking your questions one by one on rolling basis. So yeah, please make sure to put up your questions before the talk ends. And yeah, so every meetup and conference has a code of conduct. The shorter version is something like you have to be nice and please ask relevant questions. Don't spam the YouTube live chat and keep things professional. If you want to read the full code of conduct, it's over there at delhi.python.org/coc. But I don't think it's necessary for now. You can check it after the meetup. And yeah, obviously, if you want to give a talk, because we love people who want to discuss about their ideas, projects, and any interesting problem they are working on, you can head over to this link and create an issue over there. So, and we would pick the issue from over there, and you can just present a talk. And I'm hoping that I don't think we're gonna have the next meetup physical. I think we're gonna have the next meetup online, like this format. So if you found a proposal interesting, you might get a chance to present in this setup, like we're doing right now. So yeah, please just go over there and create an issue. Yeah, obviously, where to find us, and we are pretty good at social media stuff. So you can check out all of our social media handles. We are present everywhere by PyData Delhi, and you can check over there. You can go over there and follow us and subscribe to our meetup mailing list. And yeah, we are present everywhere. You can see the Illuminati sign banging right in the frame. Future meetups. So yeah, we just currently announced our public calendar, public community calendar. It's a Google calendar. You can head over to this link, and you'll be automatically subscribed to our Google calendar. And every meetup, every community call, every event, every quiz will be updated over there. So you can also keep a track of all the meetups and everything over to this link. So yeah, please just head over to this link if you want to subscribe. So yeah, I think that's enough of me, and we should get started. So yeah, over to you, Matthew.
Hi, thanks. That was a great intro. So as was said before, my name is Matthew Seal. I work at Netflix in the big data team, and I'm going to hop over the slides because it gave you a little more context as I intro myself. So let's do that real quick. Also, during this talk, you may or may not get a helpful reminder from my assistant that my cat would like to go outside. So if you hear some meowing in the background, apologies. She's very interested in killing all the birds outside, but we don't let her. So awesome. I'm Matthew Seal. We're going to talk about programmatic notebooks with papermill. As I kind of talked about, I work with the nteract group and the Jupyter group, as well as my kind of day-to-day work at Netflix. There's some overlap in there in that we use a lot of the nteract libraries and projects at Netflix, and we have a lot of the contributors to them here at Netflix, and then at places, other companies we've worked with or people who have moved on from Netflix all kind of contribute into that same pool of work. I'll explain in a second what a big data platform is, so don't worry about that one. And in terms of backend engineer, I do a lot of integrations and systems. So I work across like helping different teams able to use the product. So my customers are all the employees of Netflix right now, right? So I build tools to help them do their job more efficiently. And then we've basically leaned into using notebooks in a way to help a lot of those people be more efficient at their job. Cool. So the first thing I want to kind of talk about a little bit was what does a data platform team do? So that's a mystery even to some people who are on data platform teams. So don't be too worried if you're not sure what that means. But this picture kind of covers a little bit what that represents. So if you think about from how a business would operate as a relative to maybe a school or a personal project, in a business, you oftentimes have these data inputs. So you'll have events from people doing clicking on their devices. You'll have people typing things in. You might have your servers emitting metrics. All this data gets kind of dumped someplace. So you end up with a lot of what's called raw data, which is data that hasn't been processed, cleaned up, and unified into a shape that's known and usable. So there's this process called ETL that gets run on them. ETL is extract, transport, and load. It's a fancy way of saying make the data pretty and in a shape that you can read. And then this kind of is the basis that moves forward to a lot of different other processes that are more like maybe what you've heard of more outside of the business sectors. Things like machine learning and reporting and building data models. So these things are all kind of on the right-hand side of the spectrum where you want to get to outcomes. You want to get to something sort of that you can understand what's going on in the real world, inside your company, inside your school, and you want to have people able to make decisions. So you want to get data that lets people, either your users or yourselves, make better decisions. So what the data platform team really does, and this is the operation mode it is in many places, is they really act as a tool system that sits below all these like stages that get from inputs to outcomes. And so we build all these kind of tooling layers on top, like scheduling and computing and storage that enable these steps to be done quicker and more efficiently without having to think about as many abstractions. So it becomes really critical as companies get bigger to be able to do this efficiently, because if the data platform team can provide tools that make people above them 2x, 3x efficient, then you need a lot fewer people to do the same job. And that really helps with making people be able to get to useful results. All right, enough about big data platform there for a minute. So here we're going to talk a little bit about the open source projects we're going to go into. So really everything in this talk, except for kind of how Netflix uses these things, is going to be around what's in Jupyter and nteract. If you're not familiar with those, Jupyter is the open source organization. It makes a lot of notebook software. nteract is an extension of different Jupyter protocols into like a set of packages and libraries. So it's really an exploration of other things you could build on top of Jupyter or within the Jupyter protocol. So a lot of the maintainers of nteract are also maintainers in Jupyter. It was kind of a group that was playing with new ideas. And one of the big ones we'll talk about today is going to be papermill, which is the nteract side. Okay, so Jupyter Notebooks. And there we have our serenading assistant. Jupyter Notebooks. So one of the questions, like, what are they? Some people are really familiar with notebooks. Some people are somewhat familiar with what notebooks were 5 or 10 years ago, and some people have never heard of them. So we're going to go real quickly through what is a Jupyter Notebook and what does it mean. So in the most basic sense, a Jupyter Notebook is a like interactive website, or actually interactive document, where you have different code cells and you can execute those code cells and iterate on them. And under the hood, there's what's called a REPL, which is just sitting there and continuously accepting the commands from the cells and keeping a running state. What this means is you can rerun a later cell and all the previous run history is present, which means you can iterate on things until you get the last piece correct and then move to the next one. It also has really nice inline displays. So you get graphs and rendering and markdown and code all in the same document, which is probably its most valuable attribute. And so a lot of systems have built in display outputs that render nicely in notebooks. And these types of attributes combined make it really useful for iterative development, sharing results, and integrating various API calls. That to be said, it's not all good things. There's some things, trade-offs, costs for doing that. We'll talk about that in a minute. So one of the things, kind of a quick breakdown of what's in a notebook. You've got a status, a save indicator. So here it's, you can say like it's been less than a minute since it's saved. You might have a code cell like this one. You might have a displayed output here. And you get a lot of these wins that you get this document that kind of has everything in it. It's shareable. It's easy to read. You can put your documentation right with your code as Markdown, which is a little better than your standard commenting. And it's become a really familiar interface for people. The other thing to note here is we're going to show mostly Python code, but Jupyter, as a difference from other notebook offerings, is mostly language agnostic. So there's more tools built around it for Python use, but the execution model can run with any language. As a matter of fact, there's maybe a couple dozen kernels, which are the unit of work that does all the code cell execution. There's maybe a couple dozen different languages already implemented. Well, so I'm going to talk also now briefly about, well, how's a notebook work and what's the protocol and how's the UI linked to everything? Because this is actually a pretty confusing topic. And here we have actually, like, under the hood, there's more complexity. If you go read the source code of some of these projects, there's more layers in between, but these are kind of the logical abstractions. So if you think of like you're a developer and you're working on this notebook document, you're talking to some sort of Jupyter UI. I showed one of the Interact UIs earlier. That's a combination of pieces that have been built there. You may have been more familiar with Jupyter Classic or Jupyter Lab, which are probably the two most popular interfaces. And in any of those cases, they're talking back and forth to a Jupyter server. And that Jupyter server is sort of managing the document with the user. So there's this kind of feedback loop where you're developing and then it's kind of generating changes to your .ipmyb extension. And then it forwards requests to the Jupyter kernel. And the kernel here is a confusing name because everything in computer science pretty much is called kernel at some point. But here a kernel refers to, it's a library package which adheres to the protocol that can talk to Jupyter. So it accepts all the types of messages over the shared channel that's used to talk between kernels and servers. And it accepts those and then processes them. And then it has all the kind of pieces there. This is built in a way so that you could build different types of kernels. So long as you follow the API, you can do very fancy and interesting things with them. Most of the time, you're just using like a plain language kernel that's a wrapper on your normal like IPMYB, so like IPython display or something like that. So it's usually just almost the same as a language REPL. All right, so we're going to talk a little bit about traditional use cases and exploring them. So here we have like the standard, this used to be the classic use case for notebooks, and the notebooks are really mostly isolated to this user group for this use case. And that's what they kind of were developed out of to make their world better, where you have a data scientist uses a notebook to kind of explore different possibilities and discover which combination of inputs and model change parameters and things like that result in a good outcome. So there's a lot of exploration and analyzing, and you have a lot of heavy costs operations first, and then you're iterating on some low cost operations repeatedly. This is really good for the notebook because you could kind of do that exploration. At the end, however, you had to then sort of figure out how to get it from the notebook to an actual live system that would keep running it every day or every hour or constantly. And that was kind of a problem. So the good things in notebooks were before we kind of did some of this extra work, where they were quick iteration cycle, expensive queries. You could just run them once. You could record outcomes. So you could like save graphs of your analysis, and it was pretty easy to modify, right? You didn't have to jump between 3 or 4 systems or find some file someplace. You just had to work with the one notebook document. But there's a lot of bad things that made notebooks, and people tried to use them outside of their kind of good cases, kind of looked down upon or seen as a not good solution. And some things around this were like, it didn't have a history. So you didn't really have like, how did it change over time? They were pretty difficult to test. The document is mutable, so you can change it while you're doing things, and you don't really know when you last ran it what it looked like. They're hard to parameterize, so it's a lot of hard-coded things oftentimes. And live collaboration, and that one still today doesn't work very well. That's probably gonna change in the next year or two. There's a few offerings out there that give you different options in that space. All right, so what we jumped into with how to fill some of these negatives and make notebooks easier to use for everyone, especially for companies and engineers, as we started on this project called papermill back a few years ago. And papermill had a few kind of premises that we were trying to think about. One is we had a few things we wanted to preserve. We wanted to preserve, the results next to code, the visuals, the ease of sharing the document. But we wanted to improve versioning, mutable state, and templating because those were things that were, the lack of those meant that it was very hard to use the notebooks outside of a kind of experimental setting. So papermill was a library we built to solve some of these problems. There's other libraries I'll talk about a little bit later in here too that solve other aspects and help as an ecosystem. And there's many more past that. I won't have time to talk about them all. But I encourage you can look at the nteract repo and org and their Slack group, as well as the Jupyter and Jupyter discourse and GitHub. And they will, there's all sorts of awesome projects in there. So what's papermill? Well, papermill is a way to execute a notebook without having a browser. So it's what you would call a headless execution of notebooks. And it takes an input notebook and it parameterizes and runs that notebook, and it outputs that notebook to some output path. So here you can kind of see the diagram. You take an input, an output, and then we do some things with it. So when you're using it in code, we're going to show the code as we go because it's pretty simple to use. You can import papermill in Python. You can also use, it has a command line interface. So everything you see we're doing, you can also do with a command line. And I'll show examples of that. So here you have papermill imported, and then you can do .execute notebook. And here you give it the input path and the output path. One thing that's really important here is that we made it so that when you execute the notebook, you can output it to a unique place each time, which means you don't edit the input. So you can have a template or an example or a setup, and you don't have to change that in order to run each day or each hour. You can output to a unique path that kind of represents the run you did. And here you can see, if you were to theoretically run that, you would have, print, and you could print all the files in a directory. The other thing it supports is the ability to add parameters. So here you have a set of like basic inputs. So pretend we're trying to find out how many devices in the California region are running. So there you would do, region equals US, and then or our region equals California, and then maybe some devices. So you could give us like very basic inputs. But how does this get to your notebook? What this will actually do is inject this second cell here, which has the parameters set for you. So you define a place where all your defaults are, and then you can replace those defaults with doing parameter inputs. So this is also available as a CLI. So I'll show this the same exact command we just ran in Python. It would run here as a CLI command on any kind of bash terminal. And you can see we have the input as the first argument, the output is the second argument, and then all the parameters at the right. You can do -p for individual parameters and -y to pass YAML or JSON as an argument of key value names. Right. So what does this mean in that picture we drew earlier for Jupyter Server and Jupyter UI? Well, here you can see what it actually acts as is it sort of replaces from an execution point of view the Jupyter UI and the user. So the papermill is acting as the user. It's reading in a notebook and writing an outcome, and it's doing all the execute code and receive outputs just like the Jupyter UI did. Instead of talking to a server, it's talking to a kernel manager, which does the same sort of thing. Inside the Jupyter server, there's also a kernel manager. And they're talking to the Jupyter kernel in the exact same way you would have if you were running in the web browser. So at the end of the day, it's just following the same protocols, but allowing it to execute without having to have an active user session. And this is how it works a bit more under the hood. So here you have different input sources. And one of the other advantages that is with papermill is we made it very easy to have different sources that you could read from. So it's very easy to register a database path or a file or a service to pull your source notebook from. So you could think of things like if you're in an academic setting, it also is very easy to go grab from a mounted file system or from some blob store that's used by your school. And in a corporate setting, this means you can pull from, maybe perhaps a database, a Git repo, or some sort of like S3 blob store. And then it also takes parameters in, and those parameter values all get passed as inputs along with the notebook. And then it does this execute cells, talks to this runtime manager, it streams the inputs in and out of the runtime process. In those cases, the runtime manager is a kernel manager, and the runtime process is a Jupyter kernel. And then it stores the outputs as it executes. In the later versions of papermill, it now saves periodically and at the end of each cell. So you'll kind of incrementally get that notebook saved in the background while it's executing in case one of the cells takes a long time to execute. And then we can output to the same sources that we pulled from as sinks, which means we can save the output back to a database or a file system or blob store. And it's really easy to kind of point to any of those and it works really cleanly. And we'll show you how you can register one of those later. All right, so we're gonna also see a pattern where, well, okay, what's this really give us? Well, one thing you can do now is you can have one notebook which has how to do a particular operation. Say you want to render a graph under different situations. So say different regions that are encoded by some number. So you want to say, hey, I want to know, what's the deforestation from a satellite image over Peru for AA1, and I want to have one over Brazil, and I want to have one over, Pakistan or India or US. You can kind of iterate over those, separate them out into different inputs. So you can make one notebook that has an input pattern that says, hey, this is the name of the parameter, which determines which region or which variable I'm going to modify. Then you modify that by passing it in the papermill over and over and over again. So you can run the same notebook, give it 4 different inputs, and then you get 4 outputs that would specify the result for each of those. So maybe you get a graph per country, and you could iterate over all the hundreds of countries in the world and get some result that would say, hey, here's the state of this for each one of those. You don't have to really change your code. It's much like a function. So if you think of this as the notebook is really acting as a fancy function. All right, the other kind of interesting thing here that brought more users in is the fact that we now have this developed notebook that you can do this iterative cycling on, and you can do prep work on a notebook to make it so it can work in a number of different inputs that kind of show the results for a given a functional argument. And here now we've pulled in other users they can use notebooks effectively. The data scientist now using the notebook actually doesn't necessarily need to rewrite or pull the code out of the notebook anymore. They can just now run that notebook whenever they want with papermill. And then even we made it easy so you can just run that on a schedule. So any kind of cron task executor or data input executor can now run the notebook as if they were the user in the same way, which means you can rerun that notebook and have a high confidence it's going to run the same way. The other two groups that really have grown into using this a lot are analytics engineers and data engineers. So analyst is someone who's maybe not a professional coder. They know a little bit of code. They might know a little bit of SQL. But for them, the analytics engineer is someone who needs to get some data results, put it in a report, and kind of show some outcomes. So they get focused a lot more on like, I need this data, I need to do some basic stats, and I need to show kind of what the trend is. Maybe not as sophisticated and deep of predicting the future as a data scientist, but it's actually one of the most critical roles at companies these days. And it's one of the fastest growing ones. And this type of environment for having a notebook for them is really handy because they're not usually programmers, and the systems that exist have been really built for programmers. And this lets them kind of do everything in one place without having to leave. And then you have the data engineer. These are the people who do the first stages in that chart I showed at the very beginning around ETL. So a data engineer will do things like prep the data, clean it up, make sure it's consistent, check that you're populating everything in a timely manner, and then propagating it to these clean tables that the analytics and data scientists would use. And we actually found they end up using notebooks a fair bit too, because oftentimes they need to take some input, do a little bit of manipulation, and they usually have to iterate on that in a similar way a data scientist iterates on a data model. And so they've also benefited from this. All right. The other thing we showed earlier that how we could pull from different sources, it's actually this simple. So if you wanted to, and these are ones that are built-in support into the open source papermill right out of the box. So if you give an S3 path for an input or an output, it will know how to go fetch it from S3. That assumes you have S3 credentials on your machine. If you have Microsoft, you can go pull from the data lake and the abstract, the ABS storage. Both of those work out of the box as well. And then Google Cloud, you can also go get Google Cloud path and get things. However, it's not the extent of everything you could ever do with it. So the entire papermill library is component-based. So every part that runs can register new execution models. So what that means is, let's say you had an SFTP server you really had to talk to go get data and pull it to and from to get your notebooks. This is all the code you would need to implement that. You just have to implement that read function and that write function, make this class, make this setup in your project, and then that papermill call at the bottom will work. So it's very easy to add new schemes being the prefix on the URL path there, the SFTP. It's very easy to add new ones and then make it work for different systems you have. If you have one that's common, please do PR it back to papermill if it's like a very common file system or endpoint. We love to give that capability to other people. All right. The other thing I haven't really talked about is like reasons why you would want to use a notebook over other things. And one of the reasons here is actually for failures. Say we go back to that case where we were iterating over different countries and taking satellite pictures and understanding deforestation. If you were to run a notebook over each of those, let's say you had a failed one, you had 3 that succeeded and 1 failed. In a traditional system, if you had a failure in your job, you might have to go look through 3 or 4 different systems to find their logs to understand what happened. You might have to understand how several underlying components work in depth to understand why your job failed. With a notebook, however, you oftentimes can make it very easy to understand what went wrong below without having to leave the output notebook document that got generated. So if you had a failed notebook, it's really easy to see the stack trace, what code ran right before that stack trace, all the execution logs leading up to it. And you can see all this in the same input that you entered it. So if you read the notebook you submitted and you see these types of errors, you don't have to go read logs from a system you've never seen. You're reading kind of the code that you wrote right in place, and then what happened and what went wrong. So say we had a job where we were running a notebook and it was running a Spark job. Spark, by the way, is a very common ETL tool. So here you have a connection error that we had trying to talk to Spark, and it says, oh, hey, I couldn't reach this service. Max retries exceeded. And say, oh, well, maybe the host name for that service moved. So if we have parameterization here, let's just change the parameter and try rerunning it. And we rerun the code and say, oh, yeah, that worked. So then we have a fix for this. We can just change the notebook that ran. We've already tested that it works, and update it to have the new host name, and then everything will run and be successful. So these changes we just walked through, they really change the notebook experience in a few ways. They make the notebook isolated, so the inputs are separated from the outputs, which is really important to be able to understand what happened when. You get parameterization of notebook runs, so you can just read the notebook document, see the code that got injected for that run. You don't have to go read other systems. It'll just be code in your notebook, which means you can rerun it as well in any of the UI systems, and it'll run the exact same way it ran in papermill. And we have configurable sourcing and syncing, which means it's very easy for groups to register where their files are to papermill without the user having to copy things from that system over to the machine and back and forth. So it really gives better control of the notebook flow via this library. One thing I wanted to note, and this is something I say in all my talks on this, notebooks don't make good libraries. So try not to treat them like one. This can be a slippery slope, a difficult thing to choose. When I say notebooks don't make good libraries, what this really means is that notebooks are good as an integration tool. They're really good at connecting different pieces of technology, building a result, or taking some action against those technologies. But they're kind of difficult to understand what's going on when they get very complex and when they have a very high branching factor. Branching factor in this sense means they have lots of conditionals, like if this, then that. When they're really complex and have lots of that, and because they can be run out of order, you can get into traps where you think the notebook would run successfully end to end, but it's because you modified something deep in it, or you haven't tested all the code paths that you've written by running it once end to end. So without having good unit test capabilities, you end up getting very highly faulty code at times. So that means something is if you get really complex notebooks, you should consider maybe pulling that code into a library or encapsulating it in some way that makes the notebook simpler. Here's some development guidelines for this. Keep a low branching factor in your notebooks if you can. Push the complexity of decision branching down into the libraries that are unit tested when you can. Simple and short is better than long and complicated. Try to keep each notebook to one primary outcome. So this might be, you want to answer a particular question. So I want to know what the state of one particular situation is. If you do too many things in one notebook, one, it'll take a while to run through it all, and two, it can be confusing to digest what's going on and why you're printing everything that you are. And then try to leave library functions in libraries, move complexity when you can. I violate these rules, so you have to know that sometimes you still do that, but these are good things to keep in mind. And especially if you're sharing with other people, you want to emphasize them more. So testing, I think in the past, I haven't really talked much about testing when talking about notebooks. There's a few options out there today, and I think there's going to be a lot more in another couple of years. And then the testing story about notebooks as libraries will probably be a little less strict. And today, you can use papermill actually as a really good integration test. If you want to test that you can run the notebook end to end with the most basic inputs, papermill works great for that. We actually use papermill to test all of our templates at Netflix on the scheduling team. Excuse me. And it works very, very well. You're basically going to run a trial run of any of these notebooks and prove that they can run successfully. And if they fail, we go alert the person who wrote that template and say, hey, your template isn't working with the new libraries that got pulled in. Treon is a unit test library, but it does have it require you to put the unit tests in line in your notebook. So that can be a little noisy. If you have a large notebook, it can be a little hard to get through, but it does give unit test capabilities. So it's definitely there if you need that. MBEval, that confirms outputs match inputs in a PyData framework. So you can kind of have run of a notebook once and then prove it matches. It doesn't work for all cases, especially where you have where you expect the outputs to change slightly each time. But it is a good basis for testing a lot of notebook patterns. And then there's a work in progress thing, which I won't spoil yet because that's still being worked on. Probably over the summer, we'll have another unit test for IP and YB files via PyTest. And there's somebody in the community that's going to be working on that, which I'm very excited for. Okay, let's talk a little bit about what would an integration test with papermill look like. It's basically this. You would run papermill execute notebook or the CLI version. You would grab some template, let's say a template for running a Spark job for a user. And then you would run this and output it to some test directory where for each run that you're doing, you kind of save where it is. Then you pass in some fake things. So here, maybe we want to collect how many people are watching from a Netflix show from a particular region. And we're going to pass in the region Luna. So we're going to find out how many people on the moon is hopefully a 0, or hopefully more in the future. And then we'll pass in a run date and we'll say debug true. So maybe our template has it'll print additional things, or it won't fail if it finds no users if we say debug true. So then we'll run this, and what will happen in the notebook is you'll get a code cell that looks like this middle one, the parameters commented cell. And it'll say region equals Luna, run date equals some date in the past, and debug equals true. And then maybe in the notebook it's running some sort of Spark statement and selecting all that data for click events. And if that runs successfully and we have some validation on the outcome, then papermill has now basically let you test the integration of this tool and then. So I want to talk a little bit about some of the other goodies real quick. There's a ton of repos. There's like hundreds of them. These are a few that come to mind, oftentimes get used a lot. And these are also ones the ones I just listed here are definitely ones that could use more contributors. So would love more people that look into it. AmbiConvert has so many things it does and so few of us maintaining it. Please come help make that better. Commuter is a read-only. Actually, I'll go through and show a few of these, but definitely take a look at what's there and see if you're interested in getting involved. There's lots of things to do with these. So Scrapbook, the real quick version of Scrapbook is this saves outcomes inside your notebook that you can programmatically access. So Scrapbook lets you glue results in your notebook, and then you can read the notebook later and ask what all the scraps were. So in this first would be the cell you write in your notebook to save, say, a model or a display. And then later you can do this scrapbook.read notebook, give it the notebook path, and just ask for all the saved results. This gives kind of notebooks a return value that you can look up. Also works for images. So you can glue an image or a graph result and then collect it. A really common pattern where this is used is, say you had that fan out of notebooks where each one did a result for each region. You might collect all those region graphs into one place and then kind of show some larger graph or select the ones with the highest concern and show just the top 5. And then you have kind of a master notebook that coordinates everything. Commuter. So for Commuter, this provides a read-only interface to notebooks. It looks pretty much like this. And it lets you view a notebook without having to have a kernel, without having any compute resources. Just needs to be able to load the path. Super, super useful. We make all of our scheduled outcomes at Netflix. They all give a commuter link. So the user, when they see what happened during their scheduled run, they get a read-only view of what executed. And then we added a clone button so they can copy that notebook to their notebook dev if they want to try editing a copy of the outcome. So I'm going to talk a little briefly about notebooks at Netflix and what we use. So a few years ago, we kind of saw notebooks becoming a common interface for a lot of our users. And we took this kind of bet that if we invested in making notebooks better, it would return a lot of value to our users. And empirically, that turned out to be quite true. And we did a kind of crazy thing. It moved all of our ETL, just like tens of thousands of jobs, all onto a platform that runs on top of notebooks. So our scheduler is basically running every job as a notebook. And so everyone's like scheduled work is running on top of that. I did want to point out a note of confusion. I think that last statement sometimes makes people think we forced every single person to only develop in a notebook, and that's not really the case. So what we've actually done is we provided a notebook development to be able to be brought to production without rewriting what you've already done. When people are doing ETL, they may give us a notebook, or they may just give us a script that needs to execute in some downstream system. So they may give us a Spark script, or they may give us a SQL statement. And in those cases, what we're actually doing is on their behalf, we're putting those as inputs into a notebook. And the reason why we do that is because when something goes wrong, we can go back to that failed notebook case that we talked about, and you can take that notebook and then go see what actually happened without the user having to find all these links and figure out what went wrong. So we wrap a lot of work in notebooks because it's super convenient as a debug tool. And then users who are using a notebook themselves, the debug output is the notebook they gave us. And both of those cases, you get a lot of value without the user having to really change how they do their work. All right, so that was all of the kind of deep dive content in this I wanted to dig through. Thank you so much for joining talk on this. I think we're gonna have questions and some other things here in a minute. And yeah, I hope you found it valuable.
Yeah, Matthew, thank you very much for this talk, and it was pretty interesting. I got to see some very cool things, and I hope to use them. So yeah, we have a very good questions and the YouTube chat, and we've been taking them down. So I'm just gonna shoot the question towards you, and yeah. So the first question is by Game Spoiler. So I think that's the name. Are the Jupyter kernels also bound to global interpreter lock like regular Python, C Python, Python instances?
Yes, if you're using Python REPL, it has the same global interpreter lock. At the end of the day, it's using whatever the constraints of the language are that are underneath. So yes, in most cases, your Python will be like as though if you opened a Python terminal.
Oh, all right, all right. And we have another question from Manav Sethi. And the question is something like, so is Python the kernel for Jupyter notebooks when coding in Python? I guess the answer is yes here.
Yeah, there's the standard is usually the IPython kernel is probably the most popular and common kernel, and that is supported by the IPython project. And that's a lot of the same people that actually work in notebooks. And that one is the most common. That's usually what you're using. But if you need to branch to other things, it doesn't stop you. And there's other things. For example, we use some custom Scala kernels. There's some R kernels. There's some C# kernels. There's all sorts of options there.
Oh, all right, all right. And yeah, so there's another question by the same guy who asked this question, and the question is: doesn't executing the notebook from Python scripts kind of kill its purpose since they are meant to be interactive?
It's executing a notebook from a Python script. No, it doesn't actually defeat the purpose. So think of it this way: you're doing an iterative. As you're iterating, you're going to iterate in your notebook UI. So I'm going to try things until I get the code right. The next thing you want to do is you want to run this every time you have new inputs. So oftentimes, like the most simple case, I want to run this every day. I want to know what happened yesterday. Maybe I'm doing a 1 week analysis of how that, we'll go back to that deforestation example. Maybe I want to look at the last 7 days of forest data every single day. You don't want to have to go in and rerun that notebook manually every day. So when you get done to a point where you're ready to have this thing run on its own repeatedly, that's when you move to making a papermill command.
All right, all right. So yeah, and so we have another question from Kushal. So Kushal is one of the volunteers for PyData Delhi, and he's also present on the call. So yeah, so the question goes something like, how does Netflix handle the scalability of the system, and what challenges do weekends bring to the system? And I'm assuming weekends mean the when the rush is rush hour and the people are simultaneously logging in from the traffic is huge.
Yeah, so there's a good separation of servers. So the big data team, the servers they're running on, while they're in the same from the same pool that maybe the live stream servers are, they're pretty independent. And because we're scheduling a lot of work, if we were running out of machines overall at Netflix, we can kind of slow down how many things are running on our end to make sure that the streaming side has plenty of servers. But usually they pre-reserve those servers, so they have like a kind of emergency growth space they can go into, where they can take up all those servers in multiple regions. And so for our case, we're not usually doing things that are affecting something that you're clicking on, interacting with live. It's usually populating all the data behind the scenes, like let's say the tiles you see on Netflix to see the different shows. That might be a scheduled job that's running to build the index of all of those in the background, something like that. I'm not saying that actually is, but you can interpolate from there.
Yeah, sure. So we have another question from Rohan Yadav, and the question is, does papermill use the multiprocessing when it comes to executing notebooks? So yeah.
Yeah, no, papermill is actually a blocking process on top. However, very recently, the Jupyter ecosystem now supports async execution up and down the stack. So probably pretty soon we'll have an async command option in papermill. You can run multiprocessing on top of papermill and it will work. Just use a later version of Python. There's just one of the reasons why papermill has shifted to be 3.6 or higher. It's because some of the older versions of papermill, there were issues there that were really hard to solve permanently. So you can parallelize over papermill inside your existing process, and it'll have more multi-concurrency support in the future.
All right. So we have another question from Laksh, and Laksh is also one of our volunteers for the PyData Delhi. And the question is, how is Netflix handling the servers right now in this quarantine time? As we have seen YouTube limiting to SD version for the mobile streaming. Yeah, that's a good question.
Could you repeat just that last sentence? Sorry, I didn't quite hear it.
Sure. So how is Netflix handling the servers right now in this quarantine time, as we have seen YouTube limiting to SD version for mobile streaming?
Oh, yeah. So, I mean, right now, there's very different teams that kind of work on those two different problems. So you can think of like the different stream quality of things. That is, there's a whole huge, and actually this team does use some of the stuff we just talked about for some of their execution these days. But mostly there's this big network team that kind of has these servers all around the world. And those cache kind of the content that you're going to watch in each of those local servers. It doesn't have to send it all the way around the world to get to you. And that team has a really sophisticated and advanced setup of custom hardware, custom software. And this is something that Netflix invested a lot in a few years ago. And they built up this network. And so from there, when you're making the request, it's choosing which file to send you. So there's a bunch of copies of whatever you're looking at in different formats and different sizes of content. And then they kind of pre-plan that all out. That's a whole different part of it. Like that group is, they kind of run on their own side of things. They do schedule things back with us to like plan for like where they're going to invest more or where they need to take more actions. But generally, they kind of need to be self-sufficient to be so that if other parts of the company are having trouble on their infrastructure, they don't get impacted and vice versa.
All right. And we have another question from Game Spoiler. I think that was the guy who asked the first question. And the question is, can papermill be used in conjunction with Metaflow?
Yeah, it can. I don't seen if the open source one has a good integration yet, but it's perfectly easy to use with that setting. And there's been some experimentation internally to use in the internal version of Metaflow. Metaflow, if you're not familiar, is another Netflix open source tool for building data science pipelines. And I work really closely with that team. They've been doing some work with notebooks recently and getting better integration. So I'm sure there will be a more public documented version in the near future.
All right. And we have another question from Arnav Arora, and I'm assuming he is one of the ex-volunteers for PyData Delhi. He moved back for a master's. So the question is, since we are storing the cell results of all cells in multiple runs of a notebook, what is the storage overhead of this like? And also the notebook output file, and is the notebook output file readable?
Yeah, so when we're running these, because each run is an independent notebook, they tend to not be too big. We at the very beginning of this project, when we first started introducing it, we had to tell some people to stop saving multi-gigabytes of output logs into their notebook. You don't want to print the giant table you're trying to manipulate or copy. You want to print the aggregate results. You want to have very short, small outcomes printed. If you do really big outcomes, there's two things. One, papermill will actually run much further than your browser will. Your browser will crash way before papermill does because the browser has to do additional copies and transformations of that data that make it more expensive. So if you have a notebook, try to keep your outcomes to be like sub megabytes. You don't want, as soon as you get to tens or hundreds of megabytes, your browser starts suffering. As soon as you get to gigabytes, even papermill is kind of like trying to save this giant JSON document. So that's the advice I would give there. And honestly, it was a problem at the very beginning and very quick. I haven't had to tell anyone that in like a year at Netflix. So it's pretty easy to avoid, especially with all the tools for doing nice graphs and sampling and things like that. You don't need to pull all the data as a printed outcome in your notebook. One thing that might be confusing is the in-memory. You might hold, like we have notebooks that run with hundreds of gigabytes of in-memory content that they're working with, but they just don't print out that in-memory content. They only hold it in memory until they're done with execution, and they only print like, I'm this far done, percentage done, or here's a sample of the data I'm holding in memory that I'm manipulating, or here's an aggregate stat. And in that case, you only print out kilobytes of the information, which is totally fine for every system.
All right, thank you. And so yeah, moving on to next question. The question is by Mohit Mana, and the question is, Netflix uses Apache Hadoop open source for managing big data or any distribution. So the question is, does Netflix use Apache Hadoop open source for managing big data or any distribution?
Yeah, and matter of fact, Netflix it works a lot. We use Spark, we use Presto. We have big components and users of Pig. There's still some Pig around. But no, I would say Spark is probably where most ETL is and is going towards for us. So like we have active contributors to Spark, the company, and they're very partnered on that. I would say that's kind of the winning ETL technology these days. It does have a cost, and all distributed computation systems are kind of complicated. So there's a learning curve to it, especially for the debugging side of things. But at this point, for ETL, Spark has been winning quite strongly. And that's in the ecosystem.
Okay. So we have another question from Rohit Yadav, and the question is, can we control execution of cells?
In papermill, no. And this isn't because we can't, it's because we chose to not make it overly complicated. So papermill is a strongly opinionated tool. There's an underlying client called MB client that lets you do more customized execution. But out of the box, papermill kind of restricts you to run end to end. And this was really, so we wanted to force people who are doing notebook development when they want to schedule to have it run end to end, because it's the simplest pattern to explain to someone how it should be run. If you have to know to skip certain cells, it makes it harder to reproduce the issues when something goes wrong and rerun the notebook, because you have to know kind of the skip cell 3 or run cell 5 before cell 2. And that created a lot of confusion. So we generally avoid doing that. There's an open ticket GitHub issue about whether we should add the capability to papermill. I've been waiting or resisting to do that change because it makes papermill more complicated. That being said, if you go to that GitHub issue, we've listed out a lot of ways to work around that, where you could write some custom code and be able to do that execution yourself.
All right, so I think you can share me the issue link and I would spread around in the community.
Yeah, I can do that.
Yeah. So I think we have, that's all for the questions from the YouTube live chat. So I personally have a question for you, Matthew. So yeah, I've been using Amazon Prime and Netflix, and to be honest, like Netflix recommending system is pretty much great as compared to Amazon Prime. So I'm curious to like what yeah, I'm curious to what kind of stack do you guys use at Netflix to handle the recommendation of the users?
Yeah, so recommendation is a really complicated thing, and this is something that, and I think from stack wise, we actually use. So Netflix is built entirely on top of AWS services. So everything that Netflix does is running on top of Amazon, either EC2, S3. We basically use everything that Amazon has. So we're a very big customer of Amazon. And the for the recommendation side and how that works, there's like several large teams, one in particular that does a lot of the work there. So there's a ton of machine learning work that was started very early at Netflix to build up how the knowledge base, how to do that. Matter of fact, over the past decade, there's been like there was like a $1 million challenge with some sample data for how to that Netflix put out at one point for how can someone come up with a better recommendation that users would like more. They've been really active in trying to push the boundaries on that for a while. So probably if you see recommendations kind of group things that you like a little bit better, it's because Netflix invested a lot in that early, and a lot of the other streaming providers, are later to the game, so they haven't had those years of kind of build up to grow that muscle.
All right, it's nice to hear that. So I apologize for saying that the question has stopped from YouTube live chat because they are keep rolling right now.
Okay, that's okay.
I hope you're ready for that.
Yeah,
So
sure.
yeah, the question is by Arnav Arora. It goes like, how does papermill directly help versioning?
It directly helps versioning because we let the output be different from the input. So whenever we run scheduled, we basically recommend you don't ever set the input to be equal to the output. Technically you can, we just don't even say it. You just always set the output to be someplace else. So if you think about it, is we provide a very simple linear versioning by just always output to a new path each time. And it wasn't so much that it inherently gives you versioning out of the hood, it just makes it really easy to get versions saved. So what we do in our systems is we always pass down what the version of this notebook is effectively. And so we always put that in the output path. And then each attempt has a unique ID, and that unique ID gets put there, and then we know the order of them, and you can see the history. But yeah, the one that does help with versioning out of the box is called Bookstore. I didn't talk about that one too much, mostly because there isn't much code to look at. It's more of a tool for your Jupyter server that you can integrate with that saves your snapshots to S3, so you get versioned S3 files for your notebook, so you can look back over all the checkpoint saves. That one is a neat tool. We developed that relatively recently, but we do use it at Netflix. So when people say, "Oh shoot, what was my notebook an hour ago? Someone help, please!" We can go pull the versions for them. And later there'll probably be more UI integrations for that in the future.
Yeah, that's great. So we have another question from Game Spoiler, and I think that guy is on fire. That guy or girl is on fire.
You come contribute the paper mill. You're already like halfway there. Let's go.
Yeah. So the question is, wouldn't that possibly end up in spaghetti code but in notebook form?
Sorry, I didn't quite follow that.
Yeah, I think that is a two-parter question, and there was some previous part of that. So the question is, wouldn't that possibly end up in spaghetti code but in notebook form? So I'm assuming the last question was, the can paper mill be used in conjunction with Metaflow? So I think that's the yeah.
Oh yeah. So in that sense, yes, you can absolutely write spaghetti code in notebooks. And matter of fact, I think that's one of the misnomers, that by using notebooks, you will not have to think about all the things about productionizing your code. The reality is you still have to think about how to make your code nice and clean to share with other people. And it doesn't really matter that the medium is notebooks or script or library. You should always go through that process when you're sharing code. So you could make spaghetti code with Metaflow. You could also just make spaghetti code in your notebook to begin with in the first place. I think this kind of doesn't preclude having to do that kind of careful thought and productionization of your work. If you are integrating with Metaflow, what you would end up being is, instead of having a function as your unit of work, you'd have a notebook. So instead of passing a Metaflow a function that you want to run for this node, you say, "Oh, here's the notebook that achieves that function." and then it would run the same way. You probably have to do a little custom code today on the open source one, though there'd probably be a lot of appetite for having that PR'd into the open source. So if you took a crack at it, I'm sure other people would benefit.
Yeah, awesome. So we have another question from Harshita, and Harshita is also like one of our volunteers for the PyData Daily. And I'm assuming like I'm hoping like like 2 or 3 people would be contributing to Interact and Papermill after this talk.
You got lots
So
of
yeah,
stuff.
the question is: has Netflix explored concepts such as predicted learning to build more collaborative recommender system? Oh, great question.
Yes, I mean they do all sorts of learning systems. They try to predict social trends. They try to predict all sorts of patterns. So Netflix has what's called an A/B test culture. So that means they do a lot of experimentation tests where a percentage of people get a slightly different view or a slightly different recommendation system, and they kind of test to see, hey, how well does this work? Does this make people more engaged? Does it make them select? So people start with hypotheses like, maybe if we look at tweets from the region you're in and find out, like, I'm totally making this up off the top of my head, by the way, I don't think this is actually something done right this second. But you pull tweets in from a region, you might look at, hey, what's the kind of trending topics in there? Maybe one of them is related to one of our shows. And then they would say, okay, well, if you're in that region, let's try promoting Twitter, like popular things on Twitter in your area as like the top show to see. And we'll try that with 1% of people. And then if those 1% of people watch more, then you'll do that for everyone, right? So that's called A/B testing, and they have a lot of infrastructure and a lot of process around doing that. So there's like everything under the sun you think of different learning processes to try and give better inputs to get people to find the shows they're going to enjoy. And the way they kind of talk about the calculation of this is increased public joy. So the optimization function is increasing public joy. And then these types of things, they do try those all the time.
Yeah. All right. Thank you. So, okay, so we have a question from Manav Sethi, and the question is, I know it might be controversial, but why Amazon and not Azure?
So Netflix chose Amazon very early, before Zero really existed. So that was the short answer. The long answer is there's been a good relationship between the Amazon and Netflix for a long, long time. So we've been using their services from the very beginning. Netflix pioneered doing Spark, ETL, like Hadoop-based ETL, all S3 based, which at the time was unheard of and crazy. And they've had a lot of success. So they've kind of had a active, good working relationship for a very long time. So that's why, and it's worked well.
All right, and yeah, thank you for answering that. So, okay, the questions are getting hot. So the question is by Kushal, like he's also like one of the volunteers, and it's the second question for him. The question is how Netflix managed with the cold start problem, which is faced in the recommendation systems.
Yeah, so cold starts. Also, if we run too many questions, we should probably get ones on the notebook side of things if you have it. But I'm happy to answer these. So cold starts, typically what you do is you do a lot of caching. I mean, it's what everything does. So when you're doing cold starts, these things, a lot of the things you're looking at for recommendation have been pre-calculated, and then it's a quick lookup for which index you're going to look into. So usually there's something like the recommendation system is very complicated. So I'm oversimplifying it. But at the end of the day, it's cached a lot of the information you need to make those decisions on those local servers close to you physically. And then when you're asking that question, it's kind of just doing a lookup. It might be a complicated lookup that's like very personalized and pre-computed for you, but it's usually pre-computation and caching.
Yeah. All right. Thank you. So I think that's the end of the questions for now. And I think if anyone has any questions they want to ask, they can directly, reach Matthew on Twitter and I think LinkedIn and all the social media platforms. So as said, like yesterday, we are also having a quiz like yesterday, and there are going to be some questions that will be showing on the screen, and you have to answer that. So it's a rapid fire quiz, and the fastest ones who answer the question gets more points. So yeah, so Yes, so let's just switch to the questions. And Matthew, you are more than welcome to play the quiz. And yeah,
It's all good. I'll I will probably. I think yesterday I was doing it on my own on the side. I definitely got one wrong. So
so yeah, all the best for today. So I can so there's a link to the quiz menti.com, and the code is you can see it over on the screen. So you can just log in, and please use your Twitter name for the login for your name on the quiz, so we can identify the winners and we can give them prizes. And yeah, so I would like to say a very huge thanks to Matthew, for coming today and giving the talk. And I think the audience today of PyData Delhi had a very broad perspective towards. I think this is and in my all my years of experience of managing PyData Delhi with my team, this is the first time I've seen something like papermill, and this was quite good and quite new. And I'm hoping to get some contributors in the papermill and nteract. I'll be shooting around the message and tweet for the contribution. So yeah, please look out for that. So we're just gonna wait 1 minute for all the contestants to enter for the quiz, and after that we're gonna start. And yeah, so I think I've also stated this earlier, but we also got goodies for the winners. We have good t-shirts, notebooks, pens, and coffee mugs and all that. So I would request all of you to take this quiz seriously. So yeah, I think we have enough players. So let's just start with the quiz now. So the volunteers, can you please proceed with the quiz? So the question is, in Dell, inbuilt keyboard of Python is an object. And yeah, I have one more thing to announce for today, that we'll be giving goodies to top 5 people today for the winners. Like top 5 people would be getting goodies from PyData Delhi. All right, so let's see the leaderboard, and we have SC God 101 leading, right? And the second question would be coming up your screen just about now. So what's the output of type str? Okay, let's see the leaderboard. And we have SC God 101 leading, and the Gaurav is trailing by only by 1 point. So the next question would be on your screen right now. You can see the question, and
the trick question.
Yeah. So the next question is, what's the output for a string PyData Delhi? So yeah. And the next question is, you can see it up on your screens. All right. So let's see who's leading. Gaurav is leading by 2,380 points. The next question you can see up on your screens, and you can begin answer for the question now. Ooh, only 2 of the people got right. So Abhishek is all right. So Abhishek just won the quiz, but don't worry, we'll be giving the prize to top 5 winners for this quiz, for today's and for yesterday's quiz too. So yeah, please drop us a DM at PyData Delhi on Twitter, and we would be getting back to you with all the logistics for the prize handling. And yeah, so I think that's the end of the quiz right now, and we have prepared a small feedback for the meetup for today and tomorrow's session, today and yesterday's session. So can you? I would request all of you to please go to this link, and it will take only like 1 minute, not more than 2 minutes, to fill this feedback form. And yeah, so just you can take a screenshot of this link, or you can just directly paste it in your browser, and you can fill out this quiz. And yeah, so I think like this marks the end of this our 38th meetup, and this is like one of the unique format of meetup that we have done so far since we have started, and it wouldn't have been possible with all these awesome volunteers which are on the call right now. And so I think I would like to thank all of you for coming for the meetup, and I hope to see you in the next one, and that would be great. So, and I would like to thank each and every volunteer, especially like Arsh is responsible for the live streaming logistics, and that goes a lot of hard work and effort. And we have Laksh is responsible for the quizzes, Chetan is responsible for the quizzes, Raman is responsible for handling all the logistics for the meetup. We have Kushal, Harshita, Gaurav, and everybody has done so much for this meetup, and I'm super grateful for them. This community wouldn't be alive if it were for them. And there's also one more thing, like if you I'm assuming like you wanted to join PyData Daily community. So I think there's a link of a Telegram channel on the YouTube live chat. You can check over there. You can just go over that to the link and join our Telegram channel. And please follow us on every social media: Facebook, Twitter, Instagram, Meetup, and LinkedIn. Everywhere we are present everywhere, and just keep updated to our meetups and events. And I hope to see you in the next one. Stay safe, stay home, and be healthy. All right, goodbye.